Welcome to March 7th LeetCode Challenge. Merge two sorted lists. You're given the heads of two sorted lists, linked lists, list 1 and list 2. Merge two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists. Return the head of the merge linked list. So for example, we have linked lists above here, 1, 2, 4, and 1, 3, 4. If we merge them together, we'll have the following: 1 from the second list, 1 from the first list, 2 from the first list, 3 right here from the second list, 4 from the first list, and 4 from the second list. So ideally, we want to be able to differentiate the difference between whatever this list 1, number 1 here, came from the first list or the second list, because it wouldn't matter. However, that's where our algorithm is going to come into play. If both list 1 and list 2 are empty, return an empty list. If list 1 is empty but list 2 has a value in it, then return the value with the list with the value inside. The number of nodes in both lists range between 0 to 50. The node values between -100 to 100. Both list 1 and list 2 are sorted in non-decreasing order. Alright, so for simplicity, what we're going to do is we're going to use basically just as it states here, merge the two lists, sorted list. The list should splice one node, and the first two lists. So for simplicity, let's make a third list or dummy list that we're going to return. I call it the output list, actually. So for that, we kind of need the current list that we're working with and our output. So call it output. I'm actually going to call it our third list, list 3. Now that's too confusing. Call it current dummy or dummy. I call it temp too, but dummy sounds better. And that's going to be our list nodes. Alright, so the next thing I do is do a while loop. So while list 1 and list 2 exists or not empty, if list 1 and this value is less than list 2's value, then what we could do is that we could update the current list node next to be list 1, and list 1 we're going to reassign that or swap it with the current, and these two values are going to be updated to list1.next because we're moving to the next list 1 node, and then current is going to be the next list 1. So that's pretty much for this case. Else, then the list 2 value is less than the list 1 value, then we are going to update the current next value to be list 2, and then we're going to update list 2 to be, and the current node to be list 2 dot next, and the current node to be list 2. So that's pretty much it for that one. And so this is when they have both of the same values. And now we want to basically do this option here. So if list 1 or list 2, we are going to update the current node.next to be the list 1, or if list 1 exists, else update it with list 2. And then return our dummy.next. Let's see if this works. Alright, seems like it's all in place. There you go. Time complexity or runtime would be big O of constant space because we have this while loop here, which is our largest time running factor. Space complexity, we're storing everything inside a dummy node, which is list node, so which is a so ideally it's constant. I mean it's linear time. I mean constant time. Big O memory. It's big O of n runtime and constant memory usage or constant memory space complexity. All right, that's it. Have a good day, guys.